diagram is about. This is the whole kidney. This is one pyramid, and this is just one Bowman's renal corpuscle. Okay.
Are you done with this? I'm going to clean it.
Oh, okay. Thanks, son. Then you have the renal artery, renal vein. You have the segmental artery, interlobar arteries and veins, arcuate arteries and veins, and radiate arteries and veins. Okay? You have two sections. You have the cortex and the medulla. The medulla has renal pyramids and renal columns. The columns are in between the pyramids and hold the interlobar vessels. The pyramids have the collecting ducts in them, and they end in a papillae, and they're supported by a calyx. Once the urine drips through the papillae into the calyx, all the tissue the urine touches is going to be transitional epithelium. So the calyces, the pelvis, the ureter, the bladder, the urethras are all lined with transitional epithelium. Then looking at the cortex, 80% of the nephrons start in the cortex. These are all little baby renal corpuscles. These are radiate arteries, and you're not seeing the radiate veins because they're the ones that the radiate arteries connect to, and then the radiate veins make the peritubular capillary beds that surround these nephrons. So the radiate arteries are the vessels that supply the renal corpuscles, and the glomerulus inside the renal corpuscles is also arterial. So it makes it a very high pressure bed. So these are arteries, these are arteries, these are capillary arteries. So it's all very high pressure. The afferent artery is wider, so it delivers a very high volume. The efferent artery is narrower, so that also helps to make more pressure in here because you have a high volume coming in and trying to get out, so it makes the filter better because you have a lot of volume, a lot of filtration, a lot of pulling out, and in order to push the blood through here, you have a higher pressure in here. So you have the cortex, where 80% of your nephrons are starting, the medulla, which has the pyramids, so this is a renal pyramid, and the striations in the renal pyramids are these collecting ducts and some of the tubules from the nephrons. But basically the collecting ducts make it very striped in appearance. Then here you're seeing the arcuate vessels, here you're seeing the radiate vessels, and here you're seeing the renal corpuscles. These are all renal corpuscles. The corpuscles have the glomerulus, which is the filter, which filters the ultrafiltrate into the capsular space and then out into the proximal convoluted tubule, which is the closest one to the corpuscle. So this is the proximal convoluted tubule, where at least 80% of the water is reabsorbed, and amino acids are reabsorbed, glucose is reabsorbed in the proximal convoluted tubule. Then the ultrafiltrate goes into the loop of Henle, where salt and water is conserved, and then it goes into the distal convoluted tubule, where final secretion of drug metabolites, whatever has to leave, is secreted into the distal convoluted tubule, and then it goes into the collecting ducts through the renal pyramid and drips out through the papillae. And once it drips, then it's hitting transitional epithelium. The calyx supports the papillae, and the calyces, the pelvis, the ureter, the bladder, and the urethras are all lined with transitional epithelium because it protects against osmotic pressure and it expands and recoils. This is your renal corpuscle with Bowman's capsule and the glomerulus. The glomerulus is the filter. The proximal convoluted tubule is for reabsorption, and the distal convoluted tubule is for final secretion. And you would have a macula densa here, which handles salt. And renin is also produced here, which is a hormone. And the renin controls angiotensin, which is another hormone. And aldosterone and ADH help control the urine output. But the aldosterone's made in the adrenal gland, and ADH is released by the pituitary. So that's the kidney. Cortex, medulla. Medulla has the pyramids. The pyramids have collecting ducts. In between the pyramids are columns. At least 80% of your nephrons start in the renal cortex. Your renal pyramids have stripes in them, which are the collecting ducts. The supply of the renal corpuscle is all arterial, making it high pressure. That's really what you need to know.